Okie dokie, people. Here we go. We're going to graph logarithms. They're not that hard. Once you get the parent function, transformations are going to be exactly the same as we've done before, and we'll be able to graph them no problem. Okay. Okay. Here we go. So, parent function graphs, I'm just going to show you them. We're going to get it going. Logarithms and exponentials are inverses of each other. So, the x becomes the y becomes the x. So, in exponentials, we had a horizontal asymptote at y equals 0. Take a wild guess. Yeah, logarithms, they're going to have a vertical asymptote. I'll draw it in. A vertical asymptote at x equals 0. Okay? We're going to have two different base possibilities. If our base is greater than 1, like exponential growth was, right? We're going to have that graph. We're going to have a graph if our b value is between 0 and 1, like 1/2, right? So, let's graph it, right? So let's do an example. Y equals, let's go log base 2 of x, okay? Um, our exponential graph always goes through 0, comma 1. So we're going to go through 1, comma 0 for this graph. Again, the x becomes the y becomes the x. So 1, comma 0 becomes an important number. As we get closer to this line, we're going to approach it there, and then this one's going to head forever like this. Okay? So that's the graph of a logarithm. All right. If we have fractional, and we don't do this very often in this class, we're not going to be too mean, but if we had log base 1/2 of x. Okay. So if our base was in between 0 and 1, right? Exponential decay, if there was exponent, so there's undoing exponential decay in a way. Again, we're going to go through that point 1, comma 0. But this time we're going to go from the top. So it's going to go from here and then hit here and then head like that. Okay. So that's what they look like. You can play with it a little bit. Kind of fun. All right, so A, if we go to this, I'll highlight this here. This should look familiar. If we have a multiplier out front, it's a vertical stretch. If A is negative, we're going to flip over the x-axis. H is our horizontal shift, right? It's the opposite of what's happening, right? So if we have log y equals log base 2 of x plus 5, that means we're moving everything to the left by 5. It's also going to affect the asymptote. The asymptote's going to go with it. So if everything moves to the left 5, the asymptote's going to move over there. So we're going to have our vertical asymptote at x equals, for this case, 5. Okay, so whatever we're doing. All right. K is vertical shift, so that's moving up and down. So if this is plus 3 at the end, we move everything up 3. Now, that doesn't affect your horizontal asymptote. Think about it, or sorry, vertical asymptote, because if everything moves up 3, it stays in the same place, right? So same things we've been always doing, right? We just need to know what the parent function looks like, apply our transformations, and we should be good. All right, so looking at this example, we only have one example. This is going to be fast. All right, so we have log base 4. So as soon as I see log base 4, I'm going to say it's going to look like this. It's going to go through 0, 1, and it's going to go through like this. Whoop, there we go. So this is y equals log base 4 of x. All right, we're going to do two things to it. This is going to move everything to the right by 2. This is moving everything down 2. Okay, I'm going to start with the asymptote. If the asymptote was on the axis and it's moving right by 2, I'm going to move it over 2 and draw it in. Okay, so I'm going to draw that first. I'm going to write vertical asymptote x equals 2, just to have it down and labeled. Okay, then we're going to move everything to the right 2 and down 2. So I'm going to start with this point right here, which is 1, comma 0. I'm going to go to 1, comma 0, and I'm going to move to the right 2, and I'm going to move down 2, and I'm going to put a point. There we go. I know I have to go through that point. I know I get closer and closer to this asymptote, and I know that this is going to take off like this, and I am done. That's it. That's it, right? Easy peasy, lemon squeezy. All right. So That's all I got for you here. You can always check in your calculator. Now, here's the thing. Here's the thing. To check on your calculator, some of you have log base, and we've probably gone over this in class. If you want just a quick way to do this, remember this is log base 10, this is log base 2.7. I don't have a log base 4 sitting out here, right? So I can just use this. This should get me pretty close. Okay, so if I go on, let's go y equals, right? I'm going to go y equals ln. That's pretty close to log base 4, right? That's log base about 3. Close enough. I just want an idea of what this looks like. Then I'm going to go x minus 2, and then I'm going to go minus 2, and then I'm going to zoom 6 and see what it looks like. Boom, there we go. Now, here's the thing. Okay, you're going to look at this and you're going to be like, wait, it just stops here. It does not stop. Okay, the problem is on these old calculators, they do not have enough resolution to show this getting closer and closer to, in this case, the number 2. Okay, if you zoom in, if I zoom in, I'm going to put my cursor closer to it. Okay, if I zoom in on this just a little bit, zoom right there, and I press enter, I'm going to see it start going down a little bit more. Again, it doesn't stop there. Okay, it's going to go forever down. Okay, what happens is your calculator gets to a point where it just can't get in between these 2 points, so it gives up. Okay, quitter, quitter, right? So be careful. Your TI will show you this. Okay. So I'm just going to write yourself a little note here. Okay. This goes forever. This one, you can write in does not stop here. Okay. It does not stop there. Okay. It does continue forever, getting closer and closer to this asymptote. Okay. Okay, it does not stop there. It goes forever, forever, forever. All right, so I just want to make sure you don't get caught with that because it happens. All right, people, that's it. That's enough. That's enough out of me. We'll see y'all later. Bye. Bye.